All right. Thank you everyone for joining this virtual hands-on workshop for CAIPE. CAIPE stands for Community AI Platform Engineering. We have some folks that are organizers of this hands-on workshop. My name is Shri Arajula. I am one of the contributor and maintainer of CAIPE open source project in GNU. I'm going to just quickly read out the names. So in the interest of time, so we have Stefan, who is also, a member of Cisco Outshift. All of us are from Cisco Outshift. So Stefan has worked on building the core platform we all will use in the lab. So it's a platform that basically is a self-contained lab. So you'll really see what we mean by that in a minute. So Sujata and Noel are from our um, product marketing department. So they have graciously have been helping us with content and organizing our workshops. So we are very grateful. Sunny, Shubham, Rihan are also fellow contributors of CAPE along with Stefan and myself. And we have other contributors who have joined as not as panelists but as attendees. So again, we welcome everyone for this community workshop, and we're very excited for you to check this out and we'll do some joint learning. So we'll do some level set. Keep in mind that this is uh, uh, a work in progress open source project. So as we see any nuances and issues in the lab, we'll do some course correction in the lab itself, and we'll show you how to refresh the lab so you can play with it. So without further ado, we'll kick it off and explain what CAPE is. Let me minimize my windows here. I apologize. So I can see everybody. Sorry. I have too many panels open. So CAPE stands for, as I mentioned, Community AI Platform Engineering. Think of CAPE as like a superhero cape. When we initially developed this internally, we called the Project Jarvis in Outshift. We saw a lot of success with platform engineering and agentic AI inside in platform engineering. And as we open source this, and our marketing team came up with an interesting spin called CAPE, and which really aptly becomes a community AI platform engineering. So CAPE is a multi-agent system. Basically, it's a multi-agentic AI system that we have launched it part of this community called Cloud Native Operational Excellence GNU. It's a collection of a lot of Fortune 500 companies and other organizations that came together to really provide excellence in cloud native technologies. So we've kind of used that vehicle as community vehicle as a evolution of where platform engineering is going into more of the agentic platform engineering. So CAPE really is a way to create scalable, persona-driven AI platform engineering. We have used it internally. We have connected our internal developer portals like Backstage, VS Code plugins, even CLI to be able to talk to CAPE. And we have seen a lot of success in reducing our own, the number of cycles we spend on it. In some cases, we've reduced some tasks that would take a week down to a few minutes or under an hour. So we'll quickly show those case studies, but really the focus of this is to level set and do the lab. So I'm going to move on here, and I think most of you may be familiar with platform engineering. For those of you who haven't invested time in platform engineering, platform engineering is basically an evolution of where DevOps, SRE, and providing that DevX, developer experience, all of that coming together into providing this really awesome platform for mainly it started as a cloud first software teams, but it has evolved into pretty much any team that wants to provide that DevX solid platform engineering base to launch your products and time to market being critical. So platform engineering has evolved and it has become fairly complex over time. You see with the advent of containerization, Kubernetes, cloud native distributed systems, and as many of us who work in this space have ever growing needs to learn this technology and being able to keep our tools sharp, as well as too many moving parts when you are dealing with cloud native systems, as well as worrying about incidents. So there is a lot of uh, toil that happens in this space. So agentic AI certainly will revolutionize this space. So we were one of the first teams pioneering in this space and looking at this, and we saw that there was a huge benefit in uh, adapting Gen AI technology in this space. So we really head first dove into this as an incubation group. We had flexibility in doing that, and a culmination of that became Jarvis, and subsequently we open sourced along with the Canoe community. So just to level set where Canoe is, like I mentioned, it's some of the labels here. There are many organizations that use Canoe and they also support Canoe mission. It's about, creating platform engineering in an intelligent, scalable multi-agent system. So that's the special interest group within Canoe that's doing agentic AI. And Canoe also has tools such as IDP Builder, reference implementations for cloud native and other cloud native reference implementations. So check out the website, canoe.io, and we'll drop in some links. If one of our panelists can drop in links on Canoe, that would be appreciated. So just a quick case study here on where we saw the problem space. As I already explained, platform engineering has become very complex. Distributed systems are also quite complex. There is all the way from dealing with CI/CD, where your pipelines start, all the way to your observability pipelines, just too many moving parts and a lot of toil involved. And we as platform engineers and DevX developers want to focus on high value tasks and not worry about the mundane stuff, and use Gen AI for improving that productivity. So this is kind of like a case study that we did, like internally how we use it, and we saw a lot of impact. I'm going to leave this slide to just kind of be self-explanatory. Yeah, we've invested in knowledge bases, providing quick access to both structured and unstructured data, a lot of self-service tooling to improve automation through Gen AI, as well as a lot of stuff around code generation to ask the CAIPE tool to say, hey, create me a GitOps PR for Terraform, and then being able to review that. So this is a quick overview of how we evolved as CAIPE architecture. As some of you are maybe familiar with it, and which we'll cover this in labs. So in generative AI, typically you have something called a React loop, where you are asking an agent a question, or a large language model a question. In this case, it could be an agent, and we'll talk about the nuances of multi-agent systems. And the large language model uh, reasons on that question and acts by calling a tool. And when the response comes back from the tool, it will then again reason and say, did I meet the user query? And so on and so forth. So we kind of evolved from that architecture as a simple tool calling exercise to then introducing MCP. When we started this journey, MCP did not exist, and we kind of evolved from that journey. So fast forward, we went into this architecture called a supervisor architecture, where there are sub-agents and tools that are basically orchestrated by a supervisor agent. So it has the central intelligence to call multiple agents at a time. With the advent of A2A protocols, we realized that we may not be able to build all of the agents ourselves. There'll be a lot of third-party agents that are out there, which will be exposed on A2A and MCP. What CAIPE will become is a is an orchestrator and a flexible deep agent orchestrator that can call these multiple agents, both some that we provide first party, some you can bring as your own enterprise agents. And that's where we are evolving this. And there are more technologies that are coming together, like doing agent to agent connection over gateway and providing identity within this scope of okay, how do we do enterprise level identity, making sure that the least privilege is applied when MCP tools are called and the right set of users have access to the right set of data. So we will be able to cover some of this in the workshop. There is just a ton of information. If you navigate to our documentation page, a lot of links will be available in the workshop. So without further ado, I'm going to pass to Noel, who is going to set us up for the mission for today's workshop.
Sorry, I wasn't prepared. So here we are. We're going to start our lab today, and the mission is you and your team have landed on Mars to establish mission control operations with agentic AI. And so we will go. You'll see it in a moment, but you'll have several mission checks that we will go through, and keep the link to the Slido poll in the password, because as we progress through the lab, we'll be checking in with the Slido poll to see where you're at, if you've completed it or not, to know that we can advance forward. All of these missions will be doing different things for our Mars colony, like setting up satellite communications and weather monitoring systems. And so along the way, you'll complete those mission checks, like I said, through the Slido poll, and we'll be going over the mission shortly. Okay, and so what do you get after today's mission? So hopefully you're able to follow along with the lab with us, and you will earn some of these cool badges. So you'll at least get the Explorer badge for completing the lab today. So everybody who goes through our lab today will get this Explorer badge, and you can put it in your Cisco directory profile or even your LinkedIn profile, and we'll give more information at the end of the lab for how do you get your badge and how you can display it. For the other labs, we will have more information if you want to keep exploring CAIPE and going forward. You can earn these higher level badges: Improver, Expert, Master. And we'll give more details on that at the end of the lab. And I think we're ready to jump in to the lab.
Awesome. Yeah, so the team has been working with our internal learning folks to get Credly, and that is work in progress. As soon as we have more information, we will share that. It may take 1 or 2 weeks to get that information sorted out. But yeah, there is a discussion page on public GitHub where these progressions are listed. And yeah, you can use the Credly number once it's issued to proudly showcase that you've completed the Explorer. So without further ado, I'm going to share my entire screen and jump right into the lab. So it may be a good time. Let me stop my screen share. Stefan, it may be a good time to drop the link to the portal.
I'm just gonna put it in the chat. So that's https demos.aticloud.io. So you just access this and put your email address, and the password for the session today is CAIPE Rocks. So CAIPE Rocks.
All right.
Sorry, I made a typo. I don't know.
So while everybody is getting their lab ready, so once you land on the lab, once you go to the portal, so I'll navigate here so you all can see. and I'll grab a session myself as well. So if you put in your email address and then you put in that's the password, you say let's go, and then that will basically take you to a lab. It'll grab a lab and take you there. Here you can navigate and log in with one of the available social logins, whether it's LinkedIn or GitHub or Google. So I'm going to pick GitHub because I have already a session established here, but you can pick whichever one. This will help us know who is using the lab. And once you land on the lab, you'll see this portal. I'll continue speaking for it. In the meanwhile, you can get your lab up and ready. So we talked about what is CAIPE. There are some reference examples on CAIPE, etc. We'll skip over that. We'll focus on the missions here. I'm going to zoom in. So the first mission check would be around explaining, what are multi-agent systems. We'll do a quick example of a multi-agent of a single agent, and we'll use an MCP tooling, and we'll introduce what is A to A agent, agent to agent protocol, what is MCP, and do a quick set of labs. And then we'll dive into basically how you can run one of these agents with MCP server. Then we'll kind of dive into using CAPE to level set a pet store agent and a weather agent to communicate with each other using the orchestrator. Then we'll go into a much more complex example, which is using a RAG system, using indexing web pages, etc., and querying that knowledge base. This is using all of the functionality of CAPE. Then we're going to showcase how this whole complex system works with IDP Builder, which is one of the tools from Canoe. We'll also, if time permits, we'll do tracing and evaluation. If anything else, you have these as bonus exercises. We'll also showcase how we are building a lot of other bonus exercises in IDP Builder itself with different profiles. So there are a lot of tooling that is available in multi-agent systems, like agent gateways, how is identity set up with OAuth protocols. We may or may not have enough time to cover everything in this workshop, but we will surely do another session or another workshop. So I see a comment. We'll try this to say. Okay. I think, Stefan, we are seeing errors with Google and
yeah, give me 1 minute to check, and then
so while that is happening, I'm just going to quickly navigate one more explanation of this lab. So as you see this platform, you have these buttons on the top right corner where you can toggle between a terminal session, as well as you can open a VS Code editor. We won't really be editing a lot of code, but it'll also help you, you can just checkbox that trust the authors, and yes. When we clone the code, you will be able to visually see the code. Like I said, we won't really be editing any code here. And you can also completely skip the documentation and come back and toggle that. We'll primarily be using the terminal session here. All right, so the lab is set up in a way that you don't have to bring your own LLM key, but if you in future, if you're doing this lab on your own, we highly encourage you to because you're running many containers, especially around knowledge bases like Milvus as a vector database and several agent containers. What we have seen is having good access to at least a minimum 8 CPU, 16 gig RAM, 80 gigabytes, not GD, gigabytes of disk space is recommended. But obviously, if you're not running knowledge base, you can go smaller. While Stefan is fixing the issue with the lab, I'm just going to quickly walk through the documentation here. So this is CAIPE landing page, and this is our Git repo. So it's under github.com CNOE, Cloud Native Operational Excellence -IO /AI Platform Engineering. That's our GitHub repo. If you see the documentation page as you're trying this locally on your own setup, you can kind of dive into the quick start and see that there is a Docker Compose setup that's available. Yeah, you can test this out if you validated this. And anyway, as you're doing the lab, you'll see more and more examples of this. There is also a setup for running IDP Builder. And there is a setup for running this in Kubernetes in Kubernetes in Docker kind, or in a cloud provider like Amazon EKS, or you can run it on AKS in Azure or GKE. So whichever your preferred Kubernetes provider is, that's another option. But locally, you can run it in Docker. Although, as I mentioned, you need a decent amount of like disk space, so you're not running out of disk space for these containers.
I'm gradually deactivating this login, so
okay.
You will see more and more. So I'll let you know when everyone is unblocked.
Okay. Yeah.
Couple
So we'll continue with the first lab. I'm going to do the first lab, and I'll pass it to Sunny to do the second lab. No worries if you haven't gotten there yet. In the interest of time, I'll just kind of move along slowly. I'll level set the concepts, and then I'll skip over the actual lab itself. And when everybody is able to access the lab, we'll come back into it. So let me skip over this part. One of the things I'll only mention this one time. One of the key benchmarks and KPIs for any open source project is community support. So we highly encourage you folks to navigate to this repo, and if you would be generous enough to give a star, that would be much appreciated. But again, it's really, this is how we as a community will grow, and please spread the word if you think this is worthwhile for folks to check it out. So I'll leave it there. It's in the mission one. You can either scan the QR code or go to the repo to give a star. So let's touch on the agentic AI concepts, and then as the labs are available, we'll step through each of those. So let's kind of level set, go all the way a step back and see what is an AI agent. And if you were to kind of like look at this diagram, you'll see that it's composed of like three main components. So you're obviously, as an AI agent, you are talking to a large language model, whether it's a frontier model that's deployed in a cloud provider, or you're talking to, like, as most of you are familiar with ChatGPT, GPT-5o, or 5 or 4o, or you're talking to Claude, or you're talking to a cloud provider like Azure, GPT, or other large language models that are frontier models. The reason I mentioned these frontier models is that they have capability to do really advanced reasoning. So when you ask a sophisticated question, they are able to reason on your question and be able to interpret that question and call the right tool. So how does the LLM know the tools, right? So when you create that system prompt, which is basically an instruction that you provide to the large language model, that, hey, this is what your capability is, and these are the tools or actions you can take. And those are provided in the case of some frameworks. They are basically like function calls that have documentation strings. You'll see all of that here in a minute in the exercise. That system prompt along with the tools. And also, when you ask a question, let's say the large language model says, hey, I'm looking for more info, to be able to respond back in the same context or thread, the agent needs some kind of a short-term or short-term memory, so it knows the context of what you're talking about. And we won't have enough time to cover long-term memory. It's out of the scope of this workshop, but there is certainly work we are doing how we can incorporate long-term memory. And there is this new concept called context engineering, which there are some reference links I dropped in here in this mission. You can check them out later. So just really, again, touching base on this mission here in this diagram. From a user point of view, you typically talk to an agent. There may be an intermediate transport like agent-to-agent protocols. If that agent is exposed on an internet protocol, you will hear this phrase or keyword or this paradigm called React, which really stands for reason and act. It's a very famous paper written by some of the researchers several years ago that really revolutionized the agentic world. So because of that fundamental premise of large language models that can do reason and act, they can take input query and manage the control flow of your questions. So thereby your business logic can be written as system prompts. So that's what this one looks like. And we just quickly touched on what React Loop is. Now, let me explain this code. I'm hoping that the lab should be available here in a minute. So we have already pre-seeded an Azure key that is temporary for during the course of this lab. And by the way, this lab will be available to you till the end of the day. We won't terminate right after this workshop. We'll leave it on until the end of the day so you can check this out, at least retry it at your own pace. And yeah, again, we'll rotate the keys at the end of the workshop. We ask you not to reuse these keys anywhere else besides the workshop, and they will be rotated at the end of the workshop. So going back to this specific exercise, we're using a framework called LangGraph. It's a very popular framework to create agentic applications. There are other frameworks in this space, namely you have Strands from AWS, is Llama Index, Crew AI, there is ADK from Google. All of these essentially provide a scaffolding to be able to talk to the large language model. Basically, the three things we discussed earlier. The system prompt, how do you provide system prompts? How do you provide tools to the large language model? And how do you manage context within a conversation? So in this example, I have one tool here called check oxygen. So we have a Mars rover. We want to check the oxygen level out there. And we also want to check the battery status. So you see in my code here, we have initialized an object large language model using one of the primitives using the Azure Chat OpenAI. This is a built-in primitive from LangChain. It's a helper SDK that they provide. So, and then we're also using a built-in function called create React agent. We just briefly touched on what React agents are. And the React agent takes a large language model. It takes a tool, a list of tools. It's going to check for oxygen and battery status. And we're also telling what this agent can do. We're saying you're on a mission to Mars and you can do these things, right? Now, in the same code, I'm invoking the agent saying, hey, what is the current oxygen level and battery status, right? We're asking the agent. So we know that we want that agent to reason on that question and, basically call the right set of tools and give the answer back. So I'm going to execute this.
Sorry, Sri, can we make a stop and see if
Yeah.
everyone is able to access?
Yes,
So
yes, let's do that. I'm going to pause here. I've been talking for a minute. So as Stefan said, can everyone try to access the lab? And we should have a Slido poll here or just put it in the chat if you are able to access the lab. We'll monitor the chat. Okay, Ismail said all good. Okay, Joseph, all good, thank you. We're gonna give another 2 more minutes so that everyone has caught up to the lab. Again, as we go through this, and if we get a pretty good response, we'll move on. Otherwise, we'll do a breakout session. I think folks are, Stefan, should they still do a Google
no,
login?
there's no Google. There shouldn't be any Google.
Okay.
Just reload the page and
okay, so essentially,
just enter.
yeah, go back to your demos.eti cloud. Go to this page and put your email address and the session password is kprox. And if you say let's go, it'll assign you a session. Can everyone try that, please? Yeah, and as Eric mentioned, if you can do a hard refresh, that'll also help. Okay, awesome. Thank you. I think folks are starting to get their labs back online. I'm going to give until my time 12:37, 10:37 Pacific, then reset my view here. All right, awesome. I think looks like folks are able to access their lab. So I am in mission 2, start ignition. I just introduced the concept of React Loop, and we showed, I'm executing the first environment variable. So it just shows that the Azure keys exist. I'm not actually displaying them. We mask the keys. In my environment, typically when you develop this, you would use something like a Python virtual env, a virtual environment. I'm installing 2 packages here. One is a LangGraph package and LangChain OpenAI package. So run this step. I'm going to clear my screen. Basically, it installed both the packages along with other dependencies that come with it. Now I'm going to, this is the other thing, folks, if you may not have seen it, there is a button right here that says run in the terminal. So you don't have to copy paste anything. You can just click that button and it'll basically copy the code over and execute. So in this case, I have code already written so that I can actually write this code into a file called simplereactagent.py. So I'm going to click this button. So this will already write it into the file. I have a helper here that'll clear my screen, and I can see where I'm at. And I'm executing a Python 3 to run this React agent, right? So as I explained earlier, this agent, this is a very simple agent that has set up a LLM object to Azure OpenAI. In this case, we're using 4.0, and it has 2 tools it can talk to. And as a user, we ask what is the oxygen level and what is the battery status. So this is the question that the AI received. It made the first tool call to go get the oxygen, and then it went to the second tool, got the battery level. These are all random numbers because we're just doing a random rand in it. And then it composed both of those responses into one single response. And then it also said, yeah, both systems are in good condition. That's something that the LLM interpreted and summarized it for us. I'm going to keep going because these are simple exercises, and we have a lot more material to cover. And you can, slowly catch up to me. All right. I think I see a question that there is a module not found line graph. If one of the panelists can work with Eric, I'm going to move on. And if others are seeing the same thing, we can stop and like that. But I think, Eric, you may have missed a step earlier. So at the top, before you run the exercise, you need to run pip install. There is a step right after, before the file. Yeah. So yeah, thank you. So we're going to move to just a conceptual, what are multi-agent systems, right? So we saw a single agent running from a single file. There are a lot of different frameworks and design patterns that are proposed for multi-agent systems. We'll touch on few, and we'll also explain the evolution of where CAIPE is going. So there are, like, multi-agent systems are basically two or more agents communicating with each other in a coordinated way. Ultimately, the goal is for these agents to problem solve somewhat semi-autonomously or autonomously, again, keeping human in the loop. But largely, these agents in future, what we anticipate is if they are doing some kind of deep research or incident analysis, or they're looking at webhooks, they're able to plan and execute things, and they can also talk to other agents that they are familiar with or they know within their system, and obviously with the right set of least privilege and all the communication patterns. The idea is that a swarm or a network agent is able to communicate with other agents without a human telling that, hey, you need to go talk to this other agent. So imagine a system where these systems, either semi-autonomously, autonomously, can talk to other agents through communication protocols like buses, gateways, and be able to problem solve complex systems like platform engineering. Deep agents are another class of problems that are starting to become very popular, especially in coding. Like, you have your copilots, cursors, QCLI, and many more. So the idea here is that the agents can take a very complex question and create a plan based on their knowledge base, and also execute tools, include human in the loop, and continue in that, not just a question and answer, but they go back and forth with the user, or they can call multiple sub-agents and orchestrate a very complex interaction, a multi-turn interaction. This is what CAIPE uses today, a supervisor architecture, whereas the supervisor talks to sub-agents, and sub-agent can be itself a supervisor agent, calls tools. We're taking the evolution of this supervisor agent becoming deep agent, but that is kind of work in progress. And today, as you see in the demos, you'll see CAIPE as a much more like a hierarchical supervisor agent, calling other supervisor agents over A to A, and those agents can either call other agents or tools. We dropped in some links here so you can deep dive on these. Yeah, like I mentioned, CAIPE is kind of taking this approach and also using other patterns like reflection, where when the response comes back to the supervisor, there is like a system prompt where you can use like a LLM as a judge to say, hey, did I actually finish what the user asked for? And then reflect on that question. If not, then go back and do another turn of tool iteration, or let the user know that it couldn't find what they're looking for. I think you may have heard about MCP, which is basically Model Context Protocol from Anthropic. And it's very, very popular. the idea here is that the tools that you saw in the previous example, what if those tools were exposed by, basically you may have heard about API servers, Swagger specs. What if they are exposed by this MCP server or a specification that in the background calls an API server, or the remote server itself provides this MCP specification? So I'm not even scratching the surface of MCP, but the idea here is to basically provide the LLM, just like we were handwriting those tools in the previous example here. Instead of handwriting these code and tools, what if like GitHub provided an MCP server, which it does today, or Atlassian provides an MCP server? You can interact with those services, and they provide both tools and prompts, and be able to uh, you know, do the multi-turn conversation. So I know we are running very, very slow here on the lab. So I'm going to kind of speed up and see if I can run this lab quickly. So in this exercise, it's going to run the same package installation. It also installs an additional package. This is the LangChain MCP adapter package. In other frameworks like Strands and ADK, there are more first-party support. Here, what we're doing is, instead of those tools directly available to the LLM, we're actually running behind like an MCP server. So I'm going to quickly run that. So it's going to set it up. And now if I see the lab, actually if I do lab work, so you'll see that I have two files. One is a simple Mars MCP server, React agent. And again, you'll have plenty of time to go through this offline. The lab is available to you. I'm going to quickly run this code, which does the same exact thing it did before, but it's actually executing an MCP server in this mode called standard IO mode. Sunny will cover what is standard IO mode and what is streamable HTTP mode. We will actually use that in the lab here in a minute. So I'm going to go ahead and run this example. Clear the screen so I can have my full view, run this example. So what you'll see in this output is, because we used that adapter code with MCP, it actually did a initial list tools call so that it can extract all the tools that are available in the MCP server and then attach it to the React agent. And then you'll see very similar output ultimately, because it's calling the tool call request for individual tools and then stitching that answer together in a summary. I'll touch on this really quickly, and then we'll conclude this mission. This question comes up a lot. What is the difference between an agent and an MCP server, right? So typically an MCP server is just providing context to the agent, like tool context or prompt context. And MCP servers and the spec itself has been evolving. An agent typically is a bit more sophisticated than just the tools themselves. It can do a lot more prompt engineering. It also has long-term, short-term memory. And also, because LLMs have something called a context window, they can only fit so much text system prompt that we can give to the large language model. If you have a system like even think of GitHub, right? It has many hundreds of API tool calls. Sometimes that context cannot be fit in the LLM context window. So there are tools that are available to prune that context. All of that is outside the scope of the MCP server, right? So of course there are some advances that are happening in that space, but in a simplistic way, think of an agent is a bit like a superset of an MCP server. It has your prompt system prompts, can prune your tools, can have context engineering with long-term, short-term memory, and it uses an MCP server to do what it needs to do. Last but not least, is A2A protocol. Here, this is a protocol that was originally introduced by Google. Now it has become pretty much an industry standard, and it's donated to Linux Foundation. The idea here is for two agents to communicate over wire using JSON RPC streaming or gRPC type streaming. And we will extensively use A2A as CAIPE is a distributed agent multi-agent system, and we want CAIPE to be flexible enough that we will, CAIPE has some opinionated agents that we've written, but if you bring your own enterprise agents, you can integrate that with CAIPE and then use it in Backstage or other systems. To conclude this mission, we again highly encourage you to start the repo. Really appreciate that if you could do that. And also, you've tried out a couple of examples with a simple React agent and a React agent with MCP server. And we see that the mission is about 50% complete. You will have more opportunity to practice this offline. We are way behind schedule. So in the interest of time, we're going to start the next mission, and then maybe we'll take a breakout room. Then we can discuss both the missions. Without further ado, I'm going to pass it to Sunny. Again, all of these labs are not built on each other. If you did not get to finish this lab, no worries. The next lab is independent of each other. So without further ado, I'm going to pass it to Sunny.
Thank you, Sri. Let me share my screen. So this might take a second, as I need to. Okay, I'll be back within a minute. I have a new laptop, and turns out with Cisco WebEx meetings, I don't have the permission to share. I'll be back really fast.
Yeah, we'll check on the mission. So if you have any questions on the existing mission, there are some suggestions. Okay. Yeah. Sorry, Eric. Yeah, you can always run those commands again in the same sequence in the lab. Again, the terminals are ephemeral, so that, I mean, obviously when you do that, if you clone code, that doesn't go away. But if your terminal has any environment variables, it'll get reset. So thanks for noticing that. Sunny, if you're back, go ahead and take it over. We can hear you. Could you?
All right. Yep. So yeah, let's firstly click next button to move to the next mission, and also close your terminal so we start from the blank canvas. So in this mission, we're going to run a very simple agent for pet store. And the idea is that you can kind of, for the first time, interact with these agents. This is a single agent. We will move on to supervised agents in the later missions and be able to actually interact with the LLM. So as Sri briefly hinted, firstly, there are two different architectures that we can utilize. First one is STDIO, and the second is HTTP. So the difference is that for these agents, when they're running, they can run in, have their own MCP server running inside the agent and communicate directly through very simple text commands. Benefits of using STDIO mode is that it is faster, everything runs in one place, easier to maintain, especially for development, it will be a much faster development cycle and no authentication required. On the other hand, for HTTP case, the agent connects to a separate MCP that might be within the same cluster, it might be somewhere else. And usually it uses the web request, like calling the API over the internet. So benefits of this kind of MCP server is that one MCP server can serve multiple agents. It's usually a better idea for production deployments, and it can scale much better. And also it supports authentication and security. So you can also see the diagram here. The slight difference is the user side perspective. The interaction is completely the same. It's just that in terms of the agent actually running, here you can see that pet store agent and MCP will be running together in a STDIO mode. on the other side on HTTPS mode. They're running separately where the pet store agent connects to the remote MCP server through HTTP streaming. So without further ado, in our actual workshop session, we'll be utilizing the HTTP mode. However, if you do want to try out the CDIO mode as well, on the bottom of this mission, there's also some information on how you can do so. So firstly, we're going to follow the steps, and I'll be going through fairly fast, but obviously feel free to take more time. And at the end, we're going to give you a few minutes to finish running all the commands and play around yourself. So as usual, if sometimes it doesn't happen, you can always open a new terminal and change directory to the AI Platform Engineering repo we cloned earlier. And then we're going to firstly set up the environment variables. So we already have .imp.example file, but we're going to now copy that to .imp and populate it. So we have already prepared the LLM credentials for you. So all we're doing here is copying the variables in imp.bar file into our .imp. And you can kind of see that it has been populated. Obviously, it says stars so that we don't have to expose the secrets. And finally, we're going to populate the pet store API key. Since we're using the HTTP mode, we do need the API key to use the pet store agent. And to note here, this pet store agent is a mock MCP server we created in our team. So obviously, this isn't going to give you like a real database, but it's a very quick, easy example to try out. So now that we have also populated the pet store API key, let's finally run the pet store agent by clicking this. And what all it does is within this Docker Compose file that I prepared for mission 2, it is pulling the agent pet store peer-to-peer image. I've also described what happens here. So it downloads the image, and then this pet store agent, when it starts running, will connect to the remote server via HTTP to this address, which is our mock MCP server we prepared for you. And then finally, it will expose this pet store agent on port 8000. So we're going to still wait. It does usually take a minute or two. And perfect. So as you see here on expected output, we do see the same, that say Unicorn is running on port 8000. So we're going to now open up a new terminal because this terminal can stay open and show you the logs of the pet store agent. And then on the new terminal that you have opened up, we're first going to call this 8000 at well-known agent. So what this shows you is that it fetches the agent car, and this is how our chat CLI will communicate with the pet store agent as well. This includes information such as the name of the agent, which is pet store, a brief description of what it's capable of, as well as example commands that you can run. And we'll be able to actually show you how this then gets fed into agent chat CLI. So let's actually connect to our chat client. This once again takes a minute or two. We'll be pulling the image. And once it starts running, you'll be asked to enter token. It says optional. In our case, we're not going to use it, so just press enter. And let's give it a minute or two. Cool. So yeah, just press enter there. And as you can see, it says it recognizes this is a pet store agent. It says, welcome to pet store CLI. It has a similar description as the agent card and example skills, because at the end of the day, what this agent chat CLI is doing is fetching this identical card and be able to provide that info to the user. So now we can kind of play around. For example, I can ask, let's try this one. Show me what you can do with pets. So it's kind of quite a generic question asking, what can you do for me? And what you can see while this is running, it does take a little more time at the start because it is preparing, and you can see the pet store agent mission 2 container that is running. You see the user query has been passed on, is making requests to pet store MCP server and going back and forth, order 200, so it looks okay. And if you see, for now, because this is quite a generic question, it just says you can do a bunch of stuff related to pets and things. So now what I'm gonna ask is, how about let's get all cats that are available, because I like cats, they're cute. Obviously these are like example commands and you can try it out. And one thing to note is, okay, so there is currently one cat. It's a Earth Pet Companion. It's a Bengal, and is all-weather safe. So you can see that it is able to fetch from our existing database. And I mean, let me just try one more. Check store inventory levels. Why not? And then I'll give you guys a few minutes to, take the lab in your own time, and feel free to just play around. Okay, that's interesting. Once again, I guess one thing to note about LLM is it's not always perfect. Sometimes it gives you different answers to what you expect, but at the end of the day, what you can do is kind of change the wording and be able to try a few more times. But at the end of the day, this is getting order 200, so it is connecting to MCP server, okay? So at this point, I think I'm going to stop and then give you time to run the lab yourself. And if you have any questions, do raise hand and ask. But I'll pause for now. How many minutes should we wait for, by the way? Just any of the panelists here.
Yeah, I think we can do till 1:05 my time. I guess 11:05 Pacific.
Cool, sounds good.
And please drop a question in the chat, and we want you to be successful in these early missions so that as we lay the concept, when we go to the RAG, things will become more clearer. And we are happy to do a breakout session if you are totally stuck. I was explaining in the chat window that the CLI that Sunny demonstrated, this is something that we built. As you saw that you are able to run this Docker run, or you can run it as UBX. It does ask you for a token. In this demonstration, we did not set up these agents to either do OAuth or shared key, but that is available as of today. You can enable either OAuth or shared key for the supervisor agent. You need to set the right set of environment variables. I'll drop in a link how to do that. That will help you as you're taking these agents into production, and we'll have more guidance on that at a future, documentation link on that. Noel, if it may be a good time to launch a Slido poll for mission 3, see if we are getting good responses. All right, we have 4 people who finished. I think we'll give it another 2 more minutes as we shared earlier. And feel free to drop a question or, even post it in the Q&A. We're monitoring all of this. Sounds good. Yeah, these labs will be available till end of the day. So if you grabbed a lab, yeah, we'll leave this on, and as these are external labs, we do need to rotate them towards the end of the day. But you can at least try it out at your leisure if you join later. So yeah, Sunny, I think when you hit 05, you can kick off the next one. Just
Sounds good. I'll just wait for one last minute.
Yeah, so there was a question about the mission check numbers.
You mean like these, or?
Yeah, so is it top, it says mission check 2, but is it mission 3? Nehal Mehta has a question on that.
Okay, yeah. Thanks for catching that, Nehal. We'll get that sorted.
Oh yeah, I think it's because do you mean numbering 1, 2, 3 is a bit different to mission check 2? Yeah, I think it's because mission brief we initially thought it as like an introduction, but maybe we could have done like index 0, but with these things. Okay, cool. It's 5 past, so we'll continue. But before we move on to next mission, can I please first ask you to terminate everything? And by that, what I mean is on client CLI, you can just simply do exit. Perfect. And we can also close the window. And for this one, what we can do is probably best is we can just close this. We can Control C and then just wait for it to finish the process and make sure everything's down. If you go to just above mission check, there's stuff that can close down. So I'm just going to run that to ensure everything is removed. Cool. So once that's done, we will move to our next mission, which is slightly more exciting because this is the first one we will actually run multi-agent. So in our previous mission for Pet Store, we were running a single agent. The difference here is now we're going to add something on top. So we're going to still run Pet Store agent, but we're going to add a new agent for weather on top of it. And we will have a supervisor agent that can decide which agent it needs to redirect the question to. So instead of me going through explaining, I'll show you the architecture overview. So from client perspective, it's always the same. We're going to use the same chat CLI here. And the chat CLI is still going to fetch one agent card. And actually, it's only going to talk directly with supervisor agent. Because what's going to happen is that we basically added another layer of supervisor agent, which is then going to talk to both weather agent and pet store agent, depending on the user's request. So if user's asking anything about the weather, it might go to the weather. If it's pet, it's to the pet. If it's something that requires both, it should be able to also query weather and pet store agent and combine the answer back to the user. So let's actually play it out. Once again, I'll go through all the steps fairly quickly, but we will get a few minutes at the end to actually, play around, have fun. So firstly, going back to our AI platform engineering repo, once again, if terminal glitches out to you, we can always just open a new one. And secondly, we are going to utilize the .in file again. So it already has our LLM credentials, if you remember from the last mission, but we're going to add a few more where we actually explicitly say enable weather agent, pet store agent. The next two are for the supervisor agent, where it will be able to then do the background check to know which agents are available and be able to only give you the agent card and information for the available agents. Because supervisor agents not designed for just like pet store and weather, we'll be adding other things on top as well. So now that we've done that, let's just check that everything is set. So it looks good. And we'll start the multi-agent program. So once again, we're going to use HTTP mode for both pet store and weather agent. Let's run this and I'll quickly explain you, just because image pulling once again takes a little time. So as I explained, HTTP mode means we're going to connect to the remote MCP server. So for pet store agent, we're going to use the same MCP server that we created for you last time. And for weather, we also created a mock MCP server for weather. It actually uses the real open source API for real weather data from Earth. But obviously, this is a Mars colony themed workshop. So we have mock weather data for Mars as well. And just in time, this seems to be nearly running. So I'm going to open up a new terminal. And basically, in this case, as you saw in the architecture, we don't just have one agent, but we have 3 agents running. So the logs look a lot more complicated, and I'll just show you like what we expect the output to be for each of the agents running. So let this log keep going, and then on the new terminal, what I'm going to show is firstly, agent pet store P2P image running, and you can check the logs are correctly saying Ubicon running on port 8000. And then weather agent, very similar looking. It just says weather agent config instead of pet store agent config. Everything looks happy and healthy. And finally, supervisor agent log. And for supervisor agent log, because it is doing a lot more stuff, like actually connecting to weather agent and pet store agent, there's a lot more logs. I'm just chopping up and showing you the important line. Basically, wait before you open up your chat CLI to ensure that all of the agents are showing info message for you become running. And here you'll be able to also see a few more things such as dynamically monitoring enabled for 2 agents, which means it has correctly detected weather and pest store agent, and it is monitoring in the background. It's useful in cases where you have the deployment on and some agents might not be available. It should be able to dynamically handle that. But without further ado, let's now check the agent card. So for the weather agent card, you can see that it has a name weather, it has some example commands and description. And similarly with pet store, it should be identical to what we saw in the previous mission. What's nice about this is though, when you run the supervisor agent card, what you'll see is actually combined description of weather and pet store agent. So here you'll see examples that combines both weather and the pet store, and it'll be able to basically give that to the chat CLI. Cool. So let me run the chat CLI. So step 4, connect multi-agent chat client. Let's run this, and this one we should have the image already, so it should be fairly quick. Just give it a few minutes. Should be fairly quick. Once it's ready, once again, you don't need the token, so just click enter. And let's first ask what agents are available. Once again, the chat CLI just simply fetches the agent card from supervisor agent in this case. So you'll be able to see example skills that does combine both weather and the pet store. And when you ask what agents are available, it correctly says there are 2 agents available with some of the details they can do. So let's try something like, what's the current weather in San Francisco? This will take a little time, obviously, making the request, initially booting up. If you're curious, you can always go back to your previous terminal, which will show you the messages. So in this case, I know it's a lot of logs, but platform engineer, which is our supervisor agent, first receives the client message that we've sent, and then it correctly redirects to agent weather because this is a query about weather, not the pet. And you can see weather agent go through a lot of things because it is initializing, and then we'll be able to hopefully find some API requests to Open Meteo, which is the open source API for real weather for the Earth, apparently, which is exciting, and then goes back to platform engineers. So now if you go back, cool. So I don't live in San Francisco, so I don't know if this is correct, but I assume this is correct. It is currently 69.6 Fahrenheit with 68% humidity, and other information as well. And I guess another thing I could do is maybe get me all available pets, because now that we checked the weather agent's working, the supervisor agent also handle queries about pets. So once again, if you go back, firstly, you see platform engineer P2P logs, which is our supervisor agent. Then you can see logs coming out from the pet store agent because supervisor agent has correctly decided this is a query for the pet store agent and sent it. And then eventually pet store agent replies back to our supervisor agent. And hopefully what I should see very soon, perfect, is the list of available pets. We can also try different cross-agent scenarios and stuff. But to be fair, at this point, I will leave everyone to take it on at your own pace, try out different ones. Obviously, you don't have to just copy and paste. You can actually type in some random questions, have a conversation. So yeah, how many minutes should we wait here?
We'll do 3 minutes. Maybe in the meanwhile, you can run these cross-agent scenarios.
Yeah, sounds good.
But everybody, take the time to catch up to Sunny, and then the next mission is very exciting. It will do a knowledge base retrieval augmented generation. So Shubham and Rihan will talk about it. But yeah, check this out. These MCP servers are something we hosted. So we haven't shown you how to build MCP. There was an earlier example, but this gives you a taste of what those are. What we will do after the RAG mission is we'll run the actual scope of what we do in platform engineering. with real services like Argo CD, Backstage. We'll show a GitHub agent, and we have another 7 or 8 agents that you can talk to AWS. You'll have to run and set them up with your own credentials, but the lab will do when it's fully assembled. You'll get a full sense of how this can be used. Sorry, Sunny, go ahead.
Oh, no worries. I mean, it's mainly for people to try out. I'm just having fun as well. By the way, if you see some inconsistency today, I think, so we use ChatGPT 4.0. We're also working on upgrading it to ChatGPT 5, but currently, I think 4.0 is having a bit of an issue. So if you do see something inconsistent, I would recommend trying it out again. I guess this is why we also allow different LLM models. It's just for the workshop, we defaulted to the 4.0, but we will modify it. Sorry for that. I had a quick drop. But yeah, I think it's been 3 minutes. So should we move on to Shubham and Rihan?
Yep, let's do that. I think that'll save us enough time to do the IDP builder. And we will also introduce tracing. Some of the lab had to be reworked for tracing. So when we initially did the tracing lab, we were using an internal server. We'll show how you can reload the lab. We'll walk through it probably towards the end of the session. And then we will also show how you can run some of these and where we are headed with CAIPE as well. So without further ado, this is a very exciting lab. So we'll do lab number, I mean, it's mission 4, but it says number 5 on top. It's reconnaissance and reporting. So on to you, Shubham.
Thank you. Before we move on to the next mission, make sure you bring down the containers using the Docker compose down command in the previous mission, right? In mission 4, or mission 3 rather. So if you go to the next one, so in this mission, sort of keeping with the Mars theme, what we'll do is basically get our supervisor agent to do a reconnaissance of Mars surface and then report it back, right? And so what we'll do is deploy a RAG system, which will will index the Mars Wikipedia page, and then we'll use a GitHub agent to kind of commit the knowledge about Mars surface into a GitHub repo. So to give an overview of what this whole system looks like, so we'll have a server that and a UI that will basically where we'll sort of index our page. We'll provide the URL to index, and then what we'll do is we'll generate embeddings of the web page, and then store it in a vector DB. In this case, we're using Melvus, and then we'll have a agent, a RAG agent that will basically retrieve from it and then help the supervisor agent answer any queries about Mars. So let's continue. By the way, feel free to go at your own pace or follow along, up to you. So we'll run and make sure to have the latest the mission doc by double clicking on the logo at the top left. So let's start. So we'll just do that, and then we'll set up the environment, and then we'll start up the Docker containers. In your case, it might take a bit longer if it pulls the images. My case, I have it's already preloaded, so it's running pretty fast. So we'll wait until it all starts up. And so when you see these different agents coming up, these are not really running, but these are agents that are disabled for the moment. For this mission, we're only looking at GitHub agent and the RAG agent. So once that runs, we'll quickly check to see if it's healthy. So in a new terminal, you can always run this curl command, and this will basically should give you a JSON response if the agent is running fine. So once that is there, it's running the web server and the web UI in the background in the VM, and you can access that through this button. And this is our this is the RAG UI that we have. And so what we're going to do is we're going to copy the Mars Wikipedia page and ask it to ingest it into the vector database. And so it will go, get all the text from the Mars Wikipedia page, chunk them, and then index them. And so what you can do is to make sure that it has been indexed is you can query. So for example, you can do, let's say, axial tilt of Mars, and it should return some results. It won't really be very well formatted, but that's okay. The LLM can figure it out, can sort of ignore the formatting. So what essentially happens underneath is that we have we have the server basically fetches the URL. It has some web page scrapers, so it parses all the text out. And then if the text is large, it will chunk it, right? And we use the recursive text splitter that's provided by LangChain library. And in the future, we can support other splitters as well, depending on if it's a markdown file or any other kind of file. And then we send those texts to the LLM to get embeddings, which are basically vectors. And then we store those vectors into the vector database. So to kind of go further, I think I'll pass it on to Rehan, who can kind of go to the next steps from here. Rehan, do you want to take over?
Yes, I'll share my screen. Yeah.
Yeah.
Okay, is my screen, everyone can see my screen? So we're gonna be going through step 3, 4, and 5 with me. And I hope everyone's able to like at least see this UI and they've been able to scrape the Mars Wikipedia page. Once the scraping is done, we can just copy paste axial tilt into the query box. And you could honestly, you could frankly do anything. It's just an example, axial tilt. And then this is basically what the RAG has scraped, and this is three chunks of the most similar type of, basically a chunk that most closely relates to axial tilt. So this is the first chunk. This is the second chunk, and the chunk also has a metadata. So you can see actually that the Mars Wikipedia page was chunked into 19 unique chunks, and this is like, for example, the chunk ID of this chunk. Whatever, there are basically 3 chunks here. And so if you get output data, that means it's working fine. We can now run the RAG agent, so the actual CLI client. So I'm just going to press run in terminal. You will get this this auth, and this is something that would happen in production. Basically, the auth. Just press enter, so just leaving that blank. And you'd be welcome to the CLI similar to the previous agents. And so we can just do a test, like what's the axial tilt of Mars? what's the axial tilt of Mars? And then that's it. Like pretty much uh, press enter and wait for the agent to kind of respond. So okay, the axial tilt of Mars is 25.19 relative to its orbital plane, and that's right as well. So if I just type Mars Wikipedia and just confirm that, it's like axial tilt. Okay, there we go. Axial tilt is 25.19, so that's right. And it gives you the source as well. Obviously, in production, you can imagine this as like you have your entire platform website, you have your entire documentation, and the source would be the exact URL of where it's gotten this. Here, it's just one page, so that's just one. Um, so this is the actual explanation. So the RAG agent embeds the question using the same embeddings model to embed the documents. The embeddings of the vector space get stored in Milvus, vector DB, and the supervisor agent just does a query to the RAG agent which answers, and that's basically it. So this is, I think, a very interesting thing which we're going to walk through, the multi-agent interaction. So here we're going to get it to basically, okay, you have the entire Mars Wikipedia page. We'll write a report on the Mars surface in Markdown format, whatever, and then we will commit it to we will commit it to our repo. This is a public repo with this commit message Mars surface report with the Markdown file name as this, and this should be unique for everybody. This is basically your lab number. It's there in your URL on top as well. Okay, so let's run this in terminal. Just click run in terminal, and oh, and also you can switch back to your logs and you can see what's actually happening. So it's talking to agent GitHub. It's brought, oh, this is the actual report which the RAG agent has brought. It goes back to the platform engineer, the supervisor agent basically. And the supervisor agent communicates that back to the GitHub agent. Still working, or is it done? Oh, it is done. Interesting. Okay, I think a couple of people, it's been working for a couple of people because I can see like a couple of people have been getting their commits done. I don't really know why it's failed here. You can just try that again. I think more and more people are getting this to work, so I think it's definitely working for a couple of folks out there.
I think more importantly, if you can switch back to your terminal one, I think what you're seeing, folks, is that the report that's generated, so the supervisor agent is using that, and it's using one of our, basically it's using the GitHub agent that's talking to the remote MCP server that's published by GitHub, and you see all that tool interaction here. That it's talking to the GitHub agent, creating that report, and it's just it's a test for. This is one of like our public repos. It doesn't really have any other content in it. So the idea is how does the multi-agent interactions work? How you can create pull requests, do commits, generate reports, and that's the intent to demonstrate.
Yeah, I think it's worked this time because I've got a message that's finally been committed, and I think I'll find it here as well.
Yeah,
So,
and as more people are doing this, they probably merge conflicts and other things.
Yeah, but yes, it does work. This is my commit, And if you click on this, you will see that this is the report that's been generated by KBRAG as Shri mentioned. It's a multi-agent interaction, and the logs. You can have a scroll on the logs to see the exact tools that are being called. I think from here I'm just going to pass it back to Shubham. He's going to go through further reading. And yes.
Sure, yeah. Yeah, if you keep sharing your screen, Rehan, and let's quickly go through. So so what we showed was our RAG agent, and there's a lot of work that's being done here to support, other kind of more bigger websites and everything. But we also have GraphRag, especially for structured data. So we basically generate the knowledge graph from things like your Kubernetes resources and Backstage resources, and then do RAG on top of that, right? So that's something that you can also explore. It's not part of this demo or the workshop now, but it's you can there's a README that you can go through. Yeah. Other than that, all the agents such as GitHub agent as well as the RAG agent, they're all, you can run them, like independently. And yeah, and that's all. Yep, and there's also a troubleshooting guide if you're having issues with pushing the Mars report. I think
I would suggest
yep.
we wait for 2 more minutes. While you wait, maybe Rihan, I'll throw a curveball. If you want to index like our CAIPE docs,
Oh yeah,
and like,
sure.
and show how beyond indexing like a simple web page, how a markdown or in this case DocuSign website works. You can kind of run this in the background while folks are catching up. We will do the IDP builder at 1:35 or 11:35. Probably a little bit before that, maybe. So in the meanwhile, Sunny, you can kind of get ready for the IDP builder. Yep, as Rehan is showcasing, we've just we're indexing in the process of indexing the CAIPE documentation. This is the public docs. It's going through that. It's doing a lot of these things in parallel. It's fairly fast.
Yeah, so if I just even like query GitHub, this is the page that has been run, and you can see that it'll tell you the exact source as well, right? So if you open this, that's the actual GitHub agent being run, and I'm not sure how much this would run. Yeah, we can still give it a shot. I'm just manually saying route to KBRAG because the supervisor agent knows KBRAG just for Mars, not for agent GitHub. So let's see what it's saying. Yeah, that seems right. So it's gone to KBRAG agent, and I think it will be responsive.
Yeah, typically you wouldn't need to do that because your system prompt is like optimized for your system. But go ahead, please explain.
Yeah, so as Shri just spoke, if you even just go within the IDE and actually just go within prompt config, you will notice that basically we have system prompts for all our agents. KBRAG by default is set to platform engineering, but for this demonstration was set to a Mars. So I had to manually say, okay, route to KBRAG, but you generally don't, and it gets routed automatically based off what's in your prompt. And if we even just see this output, this is exactly what our GitHub agent speaks about. So talks about the personal access token and the API URL, and that's exactly what it says as well. It's basically a copy, a nice summary of the page. Yeah.
Awesome. Thank you, Rehan. I think we are hitting the final stretch, and this is kind of like the culmination of all the concepts we introduced. What Sunny is going to demonstrate is basically how do we run CAIPE if you are running locally with something like a IDP builder. IDP builder, IDP stands for internal developer portals. Like think of it as a Spotify Backstage open source project or your own custom developer experience platform. So Canoe has built IDP Builder as a way to quickly, rapidly prototype and bring up an IDP Builder. And some folks run this in production. So this is a way to demonstrate all the stuff that IDP Builder brings with reference implementation, the Backstage implementation. We actually, in fact, wrote a plugin that Stefan worked on that we worked with Spotify to open source an A2A plugin in Backstage. And you will see how we can interact from that plugin to the CAIPE system and in a production platform engineering context. Without further ado, Sunny.
Thank you. So yeah, I've already moved on to the next mission, but obviously if you're still on the previous one, just click next and let's once again freshen up our terminal and start there. So I'll just give it like a few seconds. But yeah, so as Shri just did a nice introduction about IDP Builder, we're going to basically put everything we've done so far kind of together and be able to bring up a local kind cluster with our platform engineer and Backstage with our plugin. So before I go into architecture details and stuff, because IDP Builder does take some time, we're going to firstly run these 3 commands. And while it's running, we're going through the details. So firstly, we're going to clone the official Canoe.io stack. This is what we're going to use our ref implementation for. And then secondly, we're also going to clone my fork of stack, which has currently our CAIPE stack called AI Platform Engineering. This has actually been merged to our official stack repo in Canoe.io, but we've also made some more improvements and we're planning to once again feed it back to the official stacks repo. But for now, we'll continue with my fork. And finally, once you're done with that, click the third one, which uses the IDP Builder CLI command. So if you look at here, it says IDP Builder create using path routing here. And because obviously we have our host that uses your unique lab, we're going to utilize that. This will be different for you. This will be whatever your lab URL actually is, and using port 8443. And as I explained, from our official stack, we're going to use ref implementation, and from my fork, we're going to use AI Platform Engineering stack. And I'll go through a bit more details about what each of these contain as well. So give it a few minutes. Eventually, you will see this log, but even then, to note that it still is deploying lots of things. It just simply means that kind cluster itself is created, but we still need to give it probably another 5 minutes for everything to be deployed through Argo CD. So we're going to firstly go through the architecture overview because the diagram explains a lot more than me saying stuff always. So what we just did is the create IDP Builder CLI command. And what it does is it deploys a bunch of different things. For example, so rep implementation stack contains Argo CD, Git T. It has stuff like key clock that helps you use authentication. It does have Backstage as well, that Canoe.io that made. However, I've actually modified the Backstage a bit to use the Agent Forge plugin that Stefan has created in order to communicate with our multi-agent. So here, what is going on is ref implementation mainly defines the core platform, whereas our AI Platform Engineering stack brings in our CAIPE. So it will be including multi-agent, which is our supervisor agent. It can connect to not just these, but much more agents. But do note that in our workshop, we are actually only deploying 3 agents, which would be Argo CD, Backstage agent, and GitHub agent. It's because obviously other agents such as PagerDuty, we also have Jira and etc. Those do require your own token. And if you want to try it out, we do have other complete stack that deploys all the other agents. You can try locally or maybe even on the lab after populating your credentials later. But for now, we'll keep it quite small and defined. So another thing is we use Vault to keep all the secrets, as we've already used in our previous missions. We do need lots of secrets. 11 credential is required for every single agent. Each of these sub-agents also require, for example, for GitHub, you will need GitHub personal access token. If you were to use PagerDuty, you need the PagerDuty API key. For Argo CD and Backstage, the reason we've included is because obviously within the IDP Builder cluster, we have Argo CD and we have Backstage. So we're actually going to auto-populate these for you and be able to interact with Argo CD and Backstage deployments that is in the cluster. Cool, so that's the rough idea. And now let's see how this is going. And you can, sometimes this does happen, don't panic. I have all the commands written. The terminal does refresh at certain intervals. Oh, and if anyone is actually trying out on local machine, this works perfectly fine on local machine. You just need kubectl installed and RDP builder and Docker desktop, something similar depending on what your machine is. But so let's firstly verify how it's going. So let's do kubectl get nodes. Okay, so obviously this is a simple client cluster, so it just has simply one node and it was brought up 3 minutes ago. Let's also check the pods, and you can see lots of different pods here. And these are also the same commands. But important bit here is that when you get all the pods, please do wait until you start seeing this backstage being ready. So for example, here right now, let me just make it a bit longer. Bit easier to see probably. We still don't see backstage. That means we need to wait a bit longer, and this is very important to wait before we continue. If any of you is familiar with K9s, I'll open up a new terminal and show you. It's quite a nice interactive tool. So once you do K9s on a new terminal, it will take a little second, but it shows you this nice UI. And what you can then do is do the double column thing, and then you can do like pods. It's already at pods actually, and then just click 0, and it actually shows you all the pods that are currently deployed in the cluster. And you can see lots of things coming up because Argo CD is still doing the deployments. But anyway, for anyone who's not familiar with K9s, we're just going to go back to our standard one, and I'm just gonna do kubectl pods a few more times. It just basically shows you all the other deployments that's getting created in our cluster. Obviously, you can see some of them are more of initial jobs completed and other things are running. Some might be having config error. It's because, so AI platform engineering pod at the start would have config error. This is kind of the limitation of IDP Builder at the moment because all our agents require secrets to be able to actually run. But IDP Builder doesn't currently allow you to pre-populate secrets upon the cluster build. So this is something we're going to address in a bit by actually creating the secrets and how you can add them to Vault. We use external secret to then sync the Vault secrets into our cluster and be able to then restart these pods to actually use those secrets. And let me run again. Okay, it is getting there. You can kind of see more things coming up. I'm going to back to K9s and then if you have any questions or anything, do let me know in the meantime. This does take a little longer. You can also see kind of different namespaces that's getting created. Once again, backstage namespace is not here yet. I think I see someone's question, but unfortunately I'm sharing the screen, so I can't see the whole thing. If someone doesn't mind reading it out loud, please. Sorry for that. Or if they could answer as well, that works.
Yeah, I think there was a question about populating system models for like SCM tools into Backstage. I'm trying to understand the question. Maybe, Srirang, if you can clarify what you mean by that. So basically, the way we're exposing various agents inside Backstage is via the plugin, and the plugin is more like using the surface area and be able to talk to the CAIPE agent. So are you able to unmute? I think maybe Sujata, if you can see if we can unmute Srirang for a second.
Okay, just 1 second. Let me try. Srirang.
Yes, please.
This loving this session a lot. My boss gave me this link and a lot. So joined a little halfway. So this is exactly kind of stuff we're trying to build, but we have a little starting issue actually. We have starting issues. We're kind of migrating some of the age-old source code within the company from like Perforce, ClearCase, and all of that to where the code existed. Yes, we do build in Popular Artifactory, but it's using different systems. So we are kind of getting into Backstage at the moment. So wanted to know whether there was any agent that kind of can take some of these artifacts as source code form or as some intermediate forms and can build the system model directly. So that would kind of populate it automatically.
I think if I understood your question correctly, are these agents available as source code, and can you like mix and match and like bring your own agents?
No. We have a starting, the whole thing in our agent journey will start with building the system models within Backstage. All of that, this uses that, depends on, has all those relationships and all that. I wanted to know if there was any in CAIPE, any agent that can go through code, just like code is being used for generating code and PRs, whether the tickets, whether these agents can go inside code and automatically build a system model inside of Backstage.
I see. I think Shubham, do you want to talk about some of the RAG stuff?
Yeah, I think this is a very interesting use case, and we don't have that today like directly, but what we are doing is basically doing that, but more for infrastructure side. But we can also extend it to code bases. With basically we scan resources and try to find figure out, hey, what is the it could be system model, but it could also be like foreign key relations and whatnot, right? And essentially create a graph out of it, right? And that can be exported out to like Backstage as like the system model, right? But we don't have anything that can like scan your source code, figure out what the libraries are, and import them into components in Backstage or anything like that yet. But it's a great idea actually, and we can look into, and feel free to contribute. Yeah.
Yeah, absolutely. I mean, we are shopping around looking for because we have zillions and zillions of projects that will be moving from age-old rich fat client code bases with million lines of code. So some of them could be small, but trying to see if there are any agents that can bootstrap some of our agent journey. I can carry this conversations on the side too.
Yeah, I think definitely join our community meetings, and we are unifying our RAG that you just saw with Graph RAG, which uses basically structured data and creating relationships. So we're basically unifying that into one. We actually, in fact, do have Graph RAG that's deployed independently of the knowledge base unstructured RAG. So the work that's happening is bringing that together. So yeah, it's a community project. Please join and check out what we have with Graph RAG. We can build something interesting together.
Thanks.
Awesome. Thank you. Great question.
Cool. Thank you. That's perfect because I think everyone's backstage is ready. If you're sick of seeing all the pods for all namespaces, what you can also do is kubectl get pods and then do -n backstage. And for me, it is all running just to make sure before everyone else proceeds, you also make sure that backstage pod is running. So if you do see this, we're going to now move on to our next step. So currently, because this is in the lab environment and this is something we need to do ensure Chrome actually allows you to open these, but we're going to just set the TLS certificate for different UIs like Argo CD, Backstage, Git-T, Keycloak to work. So that's all done and good. And now what we're going to do is, to be fair, this one, you don't actually need to add anything, but I wanted to show you that you can access these UIs. So firstly, you can get your Argo CD password like this. And I mean, this is local, there's nothing secure here. And you can then open the Argo CD by clicking the link in the docs, and it will ask you for your username and password. So username is admin for everyone, and password is what you just saw. So copy and paste, and you'll be able to see all the deployments that have happened. So do note, as I mentioned earlier, AI platform engineering is currently unhealthy. This is a limitation of IDP Builder, and we're going to populate secret next. But to show you everything else is looking green, which means all the deployment have succeeded. Cool, so going back to our doc and labs, let's go through actually configuring Vault secrets. So once again, we've just verified Vault has already synced. So we have prepared actually very nice bash script to run. And also there are two options. So as I mentioned, we're going to run a very basic multi-agent here. But for GitHub, there are two options for you. So we have already prepared GitHub personal access token for this lab, like how we prepare for LLM secrets. So you could just do echo, and then it will show you what your GitHub personal access token is, and just copy and paste that. Like copy and keep it for now, because we're going to run the bash script soon. Or if you want to follow these steps and actually fetch your real GitHub personal access token, either of them works. I already have my GitHub access token ready. I'm going to Control-C that, and I'm going to use that in a second. So once you have copied your GitHub personal access token, either actually yours or from this terminal, what you're going to do now is run this setup agent secrets bash script. What it does is it basically starts Vault CLI tool, and it will be checking for active agents. So here it detects GitHub agent, Argo agent, and Backstage agent. And as I mentioned earlier, Argo CD and Backstage, the secrets will be populated automatically because this is the local Argo CD and Backstage running inside the kind cluster. The only secret you actually need to populate is the GitHub personal access token. So here I'm just going to Control-V and then Enter. And then it takes a little time to actually populate these. You can kind of see the process. It hasn't quite finished. I'll show you what you should see at the end of it. And once you see the last line, agent secrets setup complete, that means these secrets have been correctly stored in Vault. Vault UI is also available for you to access, although by clicking here, although you don't actually need it in our workshop, so we'll skip that for now. Once you've done this, all you're gonna now do is run another bash script which refreshes secrets. So while I'm running this, I'm gonna explain to you. So as I said earlier, currently the pods are crash looping because we haven't actually populated secrets. Now that we have populated the secrets in Vault, because we're using external secrets, all this script is doing is deleting this current secret so that external secret resyncs to the latest version of the secrets from Vault. And then we're restarting the AI platform engineering pods. So these pods start with the correct secret. So once that's done, and it says all secrets and pods have been refreshed, nice. We can now access the Colony developer portal. So in order to do that, let's first grab the password. Just run this command, copy this password, and you're going to open the Backstage by clicking here, easy. Then it will come with Keycloak. So Canoe Backstage itself comes with Keycloak authentication, which is great. And we're going to sign in, and they created a default user for you. Username for everyone is going to be user1. This is also in the lab documentation. And the password is what you just copied. And once you sign in, you're in. So one thing to note, I do love a dark mode, but we currently have slight issues with dark mode. So I'm going to switch to light theme because there's a color scheme issue. So yeah, it's minor bug we need to fix, but for now, just recommendation. And then on the bottom right, you'll see Jarvis icon. This is our AI chatbot. So once you click chat assistance, it says hi there. I'm also going to click inspect. Obviously you don't have to, but to show you what's going on under the hood. Let me quickly reload that as well. And then I'll click it again. So I'm just going to say hi. Well, it's pretty fast. I'm Jarvis, your AI platform engineer. How can I help you today? So let me just say, what can you do for me? And then while this is loading, what I wanted to show you is, I'm going to go back to, let me open a new terminal. I'm going to open K9s. You don't have to, but I'm just used to using it. All I wanted to show you are some logs. So what it's actually doing is from the chat point, oh, nice, it also came back. From the network, you can see that it is actually reaching to your lab URL's AI platform engineering, which is running inside your kind cluster. And this is our supervisor agent. So this one. And you can see in the pod logs as well that these conversations has reached you, and it was then making some LLM request and be able to respond back to you. I don't think this made any like sub agent call because obviously you're just asking about generic question, what can you do, rather than Argo CD or Backstage or GitHub specific question. I did also populate some sample questions here. So let me firstly ask, what Argo CD version are you using? So while this is running, I'm going to now go back to my K9s, but instead of supervisor agent, came up too far. I'm going to show you the Argo CD agent logs. So what you should now see is that, yeah, it's received request from our supervisor agent making some requests. What it then does is we are using HTTP mode, which means it will go to Argo CD MCP server, and then MCP server will then actually make the request. And bear in mind, this is our local Argo CD server that is running in this kind cluster. So if we go back now, there you go, our Argo CD version is here. Obviously, you can also try other commands as well, but for the time being, just one more thing. So for Backstage, show me catalog version. I think this should work. It should know this is for Backstage. And then if I have time, maybe for GitHub, I'll say, I'll show me my profile details for GitHub. But once again, if you look at the actual logs, this time you'll see that it has reached the Backstage agent. And you'll see it's processing all the data, HTTP request to GPT-4o, which is the LLM model we're using, making request to MCP server, which is here. And let's see. Okay, catalog version is, yeah, fairly simple. I'm gonna also do, since we don't have a lot of time left, I'm just gonna do this last. And since I use my real GitHub personal access token, I'm hoping it will give me my actual data. But yeah, this is
Sunny, quick time
yeah.
check. We'll pause at this.
Yeah,
This
that's
is a
fine.
fascinating, fun demo, and also this is how we internally use Jarvis and CAIPE. One thing I want to highlight is that so this uses Keycloak and OAuth. We do need to set up. That means the users. You all need to do the A2A OAuth, and I sent the guidance there. Yeah, finish your thought, and I'll close with tracing, and we may go 1 or 2 minutes over. But
Yeah,
we'll
sounds good.
kind of explain tracing. You can try it out offline, and then we'll close the mission. Go ahead, Sunny, if you can close it out.
Yeah. Oh, I thought you wanted to take share. Sorry, I've stopped mine.
Yeah, no worries. You can finish like if you need to close anything.
Oh, it's okay. I mean, I think everyone saw the GitHub also worked. I guess one thing is obviously this is basic model, but like we're not limited to certain sub agents. It is open source. If you have a good idea about certain sub agents, we can always add that. We have a Helm chart. So this is how we're using our DB builder. So yeah, it's just a very small example of what it's actually capable of. Yeah, go ahead, Sri.
All right. I'm going to do a very quick intro about Mission 7 that you can try it out. There are a lot of libraries out there that you can do tracing and evaluation. Our goal ultimately to bring the level of determinism, the type of field we are in DevX and platform engineering, we want high level of determinism with our multi-agent systems. So we've invested in evaluations for a good year now. We've done a lot of different evaluation, statistical evaluations, trajectory being one of the more popular ones. So we've done correctness, LLMS judge. There is a framework part of the agency collective called a metrics compute engine. So if one of you, Noel or Sujata, if you can drop a link there. I think we're going to use that along with, like, there are a whole bunch of libraries for evaluation, deep evals and ragas and others for RAG. We have taken LangFuse as an open source library. There are, like I said, plethora of enterprise tracing solutions, both like Langsmith being popular and Traceloop and others. And there are some on the commercial, on the open source side, along with agency libraries. So what I wanted to show, I can't actually demonstrate this. In this mission, you will run a Docker Compose that will bring up the entire LangFuse along with ClickHouse and other components in it. This mission, it's probably best if you run it on your desktop because some of the wiring is not set up properly. We were using our own internal system, which we couldn't expose internally. So I would probably skip the lab and just go straight to the repo, download mission 7. You can still use the same script. The idea is once you run the script here, I'll show you my my editor here. So I'm running my local browser here. I have already, let me run like few queries. And then what I wanted to show you is the actual like LangFuse UI. So you can see the traces. So maybe in the interest of time, I'll do that. So once you set up your LangFuse, you'll just sign up with your email address. It's just a local sign up. So you'll go to your project. I just named my project CAIPE. So I ran one example with weather. So I said, okay, what's the weather in Allen, Texas? And you'll see we've done some work actually chatting with even the LangFuse folks to understand how we do distributed tracing, how trace IDs can be passed via A2A between agents. So we've actually annotated each agent. So you'll actually see that there are 2 agents here within the distributed trace. This correlation was not, it's not there out of box. So we had to stitch them together through some correlation. The idea is that, yeah, we're using OTel. So this is all OTel traces. So LangFuse uses OTel traces. So does pretty much all popular libraries like Agency, Observe, SDK, and there are other OTel compatible tracing libraries. So what we've done, and you can follow some of our examples, we've written a utility library that can annotate all the agents. That's how we are getting the agent annotation. The reason why I'm emphasizing is that if you are doing a trajectory match, you need to know where your query is going. Like it starts from the supervisor, which tool it's getting called. And in this case, it's calling something called a weather tools agent, which actually under the hood is transporting that over A2A to a weather agent. And then it actually calls a get current weather tool. And we have data sets within our like evaluation framework that will go through all of this and say, okay, for this query and data set, this is the right trajectory. We do some statistical analysis so that to know how accurate our multi-agent systems are. So we will publish some more results on CAIPE. This will also help if we are comparing 2 frontier models with the same data sets, and more and more of this is coming. As I mentioned, the caveat with this lab, I'm going to still share one more minute and then finish up. This is best to try it out locally. One last thing I will mention, we have been working on these profiles. As Sunny demonstrated, we have a basic profile. That's what we showed. We have a complete profile with all the agents running. We are putting together something called a SLIM. It's a PubSub, very low latency PubSub architecture between agents that agents can talk A2A over SLIM. On top of that, there is another open source project called Agent Gateway that can be used for MCP. we're putting all of this together. We will show when this is merged into the main stacks, we'll have detailed documentation on how you can try it out. And last but not least, I will say there are some bonus labs. Welcome to try it. We want you to join our community. As I can emphasize, this project cannot be successful without community and folks like you who join, take time away from your day job to join this. Please participate, start our repos, look at our PRs and contribute, or use it and give us feedback. So anything and everything is welcome. And I left the QR code when we meet in the community. And with that, I want to thank our panelists and everybody who presented. And also thank you for joining and giving us valuable feedback. And yeah, thank you. We'll hang out here. Feel free to ask or post any questions. We'll hang out for a few minutes.
Yeah, Shri, you can bring up the badges again to remind them the badges that they can
And
earn.
also, if we keep the labs longer, how long do we keep them?
Till the end of the day. Let's plan for end of the day. And if you all have any, if you're in the middle of something, just send us an email. We'll work something out. But
Yeah, we really appreciate your comments here. And Noel sent a Slido, so please, if you have not already put your feedback there, that will be great. WebEx will be sending you automatic feedback after the fact as well, and we'll share the recording. So if you can put the same feedback in the surveys that WebEx sent, that will be really helpful. It will put everything in one place for us for reporting. Thank you. Yeah, go ahead, Shri.
Yeah, as you mentioned, the badges are here. All of our discussions when we introduce new technology, we post it here. So yeah, please come back and check these announcements, our release notes. We're fast moving along with the fire hose of agentic AI. So we really appreciate all the kind comments, and we would like to see you guys back in our community meetings.
Yes, so the recording will be shared with everybody who have attended today's session or even registered, because we have their emails. And Shri, if you feel comfortable, we can maybe post it on the community as well. I don't know if we can do that. We have
Yeah,
ability.
absolutely. We'll put. I don't think there is anything sensitive here, so we will put it on our Canoe YouTube channel and share it with the community.
Yeah, awesome. Somebody is asking if we can meet physically.
Yeah, I mean, so I'm based in Texas, Allen, Texas. So if you guys are in Bay Area, so Stefan is in Bay Area, and Sujata, you guys I think are in somewhere in that big sphere of Bay Area. We have folks in London. So Sunny, Shubham are in London, and Noel, myself, we are in Texas, but farther apart. So yeah, if you are also coming to KubeCon. I'll be there for one day at KubeCon, so that's another opportunity to meet. And if you are at any conferences, Srirang, we would love to meet up. And also, let's connect in the community spaces. Our webpage has a link to how to join the Slack community space. So if you all join the CNCF Slack, you can go and find the Canoe SIG Agentic AI channel.
Yeah, and again, a reminder, I think Noel posted the link to give us a star on GitHub, right? So
yes, yeah, please, and that's very much appreciated. As we said, communities like us, we grow by adoption. So, Srirang, I'm not sure if any of our team is going to GitHub Universe. I know Shubham is presenting at Neo4j conference, and there are a few folks who are going to reInvent. Hasid, my manager, is planning to go to reInvent. There is actually CAIPE will be presented at reInvent. Some of the agents that are in the Argo CD ecosystem, we built. Carlos Santana from AWS and myself, we will present that at the ArgoCon in the KubeCon conference.
Okay, I think it's a good time to drop because we're already 10 minutes over. But I don't know if people have some.
I think we can definitely stop the recording and yeah.
Okay.
Yeah, nice meeting you, Shriram. Thank you. Yeah, we'll definitely connect offline.